Okay, so tonight we have the presentation here for the ATSC 3, and the co-organizers with me are Craig and Sylvia. Sylvia couldn't come. Craig, where are you? There he is, in the back. And Orst Suko and Willie Perez will be doing the two presentations tonight. And Orst we just heard, and Willie is right here up the front. So, sponsors tonight. We have Avatech, and where is Alex and Vlad? Back in the back there. Can you stand up? Because we're going to give you a round of applause. And we got Channel Zero as well. Where's Brian? Brian, can you stand up? From Channel Zero. And then we got the college here, Orst, Willie, and the support team back there. And we've got name. Ginger. And the various faculty members that are here as well. So we thank you as well. Yes. And SMPTE Toronto TTC 2023, which is in June. So we're trying to make some plans for that as well, also sponsored. So before, whoa, that's kind of fast. So before I go forward, just some house cleaning. We just had an election. Oh, I see. What's that? Wow. So it's interesting how PowerPoint takes over. You should never carry a PowerPoint over from one computer to the other. So that's the error of a PowerPoint transfer from one system to the other. So I'm a chair, and Sylvia still is the secretary treasurer. Lee is still the past chair, and Troy is still. So all of us are in the second of our 2-year plan. Managers, we have Jason. Jason's in the house. Jamie is not in the house, and Randy's not in the house. They are new to the board. And then returning is Stosh is in the house, or he had to go? Oh, Roy is returning, and Craig is in the house because we pointed him out earlier. Oh, wow, that is really formatted area. So Savino and Nathan is new to the board, and Jeff is returning. So Jeff is here in the house as well. And then we have a membership chair, a promotions chair, and a student advisor chair. Nadia, Peter, and Richard, they're all returning. Peter's at the back of the house. He's taking care of the recording tonight. Oop. And then Western Canada subsection, we have both Brian Grattensby and Rick Cederlin as chair and secretary treasurer. They're returning, and they're in the second of the 2-year term as well. So this evening we will have our presentations. Then we're going to have our tour, and we'll describe on how we're going to do the tour after the Q&A period, because we're going to break everybody up into groups and things of that nature. But we'll have more information on that later. So, has everybody heard about ATSC 3.0? Everybody got a TV at home that takes 3.0 signals? Maybe no? What's that? Yes, I do. And thanks to Willie, now I can get the signals that I couldn't before. So, No, but if you're in Canada and you put your TV to Canadian because you're Canadian, and that's kind of what the manual says, put the region in that you live in, you won't get 3.0 because Canada is not sanctioned to have 3.0. So you got to tell the TV that you're an American. And once you do that, then you get all the 3.0 channels. But Orst and Willie are going to describe what all that means during their presentation. So Orst, I'm going to read his bio here. And Orst is a graduate of McMaster's and Ryerson, which is Toronto Metropolitan, I guess now, universities. and a Fulbright specialist. With over 30 years in experience in the broadcast, film, post-production, and music in the field of audio engineering, Orst has garnered him an Emmy Award, 2 Emmy nominations, and a Cinema Audio Society Award, numerous international recognitions. His interest in applied research has focused on emerging audio technologies, design, and functionality in the mobile SDK application. He has led a research team as principal developer in developing audio watermarking technologies. Orst has been undertaking research with the new ATSC terrestrial transmission standards since 2018 and brought the vision of B2C lab to Humber College. So I'll do both at the same time, or do we want to do one then the other?
It's up to you.
Okay, we'll do both. Now, Willie, up front here.
Yeah.
Nice picture, by the way.
Yeah.
Yeah. So Willie, his bio reads, Willie has more than 30 years in the broadcast industry as a broadcast transmitter engineer with demonstration histories of working in the broadcast television industry, worked from the production of programming to editing media, assets management, ingest using satellite technologies, and file flow, automation for on-air and TV transmitter operation and maintenance. He worked as a broadcast transmission tech with Rogers Media Inc. for more than 13 years. Introduced the use of ubiquity links for transmitting HD SDI over IP between sites that saved Rogers Media big bucks. Created some SMPTE apps using C and Visual Basic for transmitter control and monitoring for the Rhodes and Schwartz and Thales transmitters. Willie worked as transmitter engineering for Thales, French company joint venture with STESA, which is in Riyadh, Saudi Arabia? For 13 years. Well, that's 13 years. 13's a good number for you.
He's only 29.
Willie worked with the biggest broadcasting company in the Philippines as engineering supervisor and provided technical assets or assistance with and supported 22 affiliate stations throughout the country. Willie is a former member of engineering faculty from a variety of universities, giving lectures, performing lab experiments in the digital electronics and communication systems. Willie and Orst, I move the floor over to you guys.
Thanks very much, Tony. Welcome, everyone, to our September 2022, I don't want to say annual barbecue, because it's not quite annual, but we hope it becomes annual here at Humber College, and we graciously welcome SMPTE and all of you here tonight. I'd first off like to acknowledge our Humber executive that are with us this evening, including Gina Antonacci, our Senior Vice President of Academic. I'm following the order and the protocol that Tony established. And Derek Stockley, our AVP of Academic. And Ginger Grant, our Dean of Research and Innovation. And I'd also be remiss if I didn't note the tremendous support that we've had from the BCTI and Neil Mohammed, the director of the Barrett, who's also with us here tonight. And I'd be even yet more remiss if I didn't mention our real amazing Humber Lab team, which includes Willie Perez, who you'll meet later on, Alexander Yubova, our lab industry project manager, who's running around keeping us moving tonight. Thanks so much. And as well as Himanshu Sharma, our lab technician, who's with us here. Himanshu just tipped his hand up there. And our amazing staff in the Office of Research Innovation who provide us daily 24/7 support. So with that, I also wanted to acknowledge or re-acknowledge our sponsors, our generous support for this evening from Alex and Vlad at Avitech and Brian at Channel Zero, as well as SMPTE and here us at Humber as well. So thank you to everyone. So this evening, we're going to provide you kind of a high level. I'm going to start at 100,000 feet with the lab, and between myself and Willie, we're going to bring it down to ground level. And the true ground level will be the latter part of the evening, which will be the lab tour. So we're going to take you sort of from kind of concept to the state of operationalizing that we are at right now. So I'll start off with sort of an introduction and address infrastructure and engagement, and then Willie will move on to the actual ATSC3 over-the-air test bed that we're in the process of undertaking construction on here at Humber. So we are sitting in what's known as the Barrett Center for Technology Innovation. You've all now had a chance to taste our hamburgers here at the Barrett Center, or I should say the Simply Barbecue hamburgers. This is a 93,000 square foot facility. It houses a number of consortium partners, including Cisco Canada, Six Sensors, Rockwell Automation, Magna International, KUKA Robotics, and Festo. Thanks very much, Neil. And it's very interesting for us to have our lab situated actually on the 4th floor of the center. As the broadcast industry looks at and considers adopting to and digitally transforming to an all IP-based standard, the broadcast industry can actually help other industries digitally transform. And the companies that are operating in this building are very interested and centered around a strategy of Industry 4.0. And Industry 4.0 requires support in terms of data delivery in many cases. So this is where we see a lot of great potential synergy. And we hope over time that we'll actually develop relationships with these companies or some of them that want to explore what ATSC3 can offer in terms of its data casting abilities. So you'll see our lab up on the 4th floor once we move to that part of the evening. So quick level introduction here. We are establishing ourselves as the first R&D testbed in North America that's equipped with an ATSC3 IP-based ecosystem, sort of a full end-to-end production system, and a 5G core network that'll combine the best of these two standards. For us, that's very key. We understand that there are 5G labs at other academic institutions that undertake research, but we wanted to offer the value proposition of putting a 3.0 system together with a 5G core system and to actually develop a research roadmap around convergence of those two data delivery standards. You won't see our 5G core tonight. It's in the process of procurement. But that if we come back here next year and we're blessed to have another round of hamburgers, you will undoubtedly see our 5G core. So there's reason enough to want to come back to us at Humber. Our third technology cluster that you'll see tonight is a custom RF anechoic chamber that's being installed as we speak. It's designed to get us down to about 450 megahertz and up to about 20 gigahertz at this point in time to allow us to develop and test and design a range of prototypes, sensors, antennas, et cetera. So some of this is key for some of our specific partners, and other attributes of the lab will be key for other partners that are coming in over time as hopefully the standard proliferates. We're also in the process now of just finalizing our 3.0 developmental licensing. So at this point, it looks like we'll be first in Canada with a developmental license with 3.0. So that's really exciting for us because we want to offer a home to stakeholders who want to come experiment with the standard. And as the 5G core goes in, we'll consider the best sort of implementation of that, whether that involves transmission on the PHY layer immediately or whether it involves convergence with 5G on the transport layer or the application layer. And that'll be something that's developed. The developmental licensing will develop over time with that. So we've got an in-lab RF setup, which I'll detail at a high level before Willie gets to the 3.0 testbed, as well as the over-the-air system. And our coverage area is, or in terms of our location of infrastructure, it'll be here at North Campus. We'll have our main mast here on top of the Barrett Center. I'll show you a map slightly farther down in the presentation, as well as a second TRX site at 110 Carrier Drive, which is located about 1.5 kilometers north of the main campus here. That's the Humber Technology and Trade Center. We'll have a third site, TRX site, located down at Humber's Lakeshore campus, for those of you that are familiar with the South Etobicoke area at Lakeshore and Kipling. So we'll have those three sites in our first phase of OTA development. So this is the lab showcase that you'll see upstairs. We are very fortunate to have been able to set up the actual lab in a configuration that allows us to present it as a showcase. So when we have larger groups, as we have tonight, to be able to tour the lab, we don't have to squeeze everyone in between the racks. We can actually have them be able to participate in a tour just outside the front glass of the lab. So the way Willie's has it racked and fired, it's very convenient for us to be able to use this space as a classical sort of broadcast showcase. The main room of the lab you see right now is in what Barrett refers to as a makerspace. So this is where industry and industry partners actually do some of the physical work. So we've procured this space to house our RF chamber. And as you can see, we have multiple TVs running right now for some interoperability tests that we're conducting with one of our industry partners, Sinclair Broadcast in the US. So there's racks of RF microwave equipment, essays, et cetera, that are housed in the back part of the lab. So the showcase just sits to the left of that image. But again, you'll see that more clearly when you're upstairs. And this space here encompasses a number of industry project rooms. So the beauty of the Barrett is that it's all interconnected. And the other beauty of the Barrett is it kind of allows for a natural sort of incubator environment where you can have industry partners come into the space and you can have multiple partners working concurrently. And we could, through our specific setup, have multiple partners working in individual rooms, and we can actually split out our ATSC3 signal to provide research and development of specific use case applications in those specific project rooms through local RF and through local internet connections that are or Ethernet connections that are available in each of those rooms. So looking at it from a top level, you've seen the chamber space, which has the small RF chamber logo there, the showcase space, which is in the front part of our makerspace, and then the 6 project rooms. So those are all interconnected with Ethernet and RF drops to allow either television or non-television applications, data casting applications, or any other sort of data delivery models that use RF to be deployed in any of those 6 individual rooms. So for us, the way our lab grant operates is that we have the capacity to be able to work with more than one partner at a time, and that's very important for us. So again, breaking it off into a couple of main research themes are, I won't call it necessarily primary and secondary, but 2 sort of attributes to the standard is its ability to deliver new television experiences. And we certainly want to be able to explore that with certain industry stakeholders that are interested in developing television applications where you can merge real-time and non-real-time events and sort of recontextualize the broadcast experience. For us, that's really key to offer that. That can include addressable advertising, content substitution, and enhanced emergency alerting. The other aspect of 3.0 is that it can serve as a capacity multiplier. So it could mean that traditional market adoption strategies like front-facing next-gen television could be just one of several adoption strategies for new territories. One of the things we want to start to look at are these 3.0 5G hybrid architectures where we can look at broadcast offload. So if mobile networks are getting congested, if there is a live sporting event or some event where the mobile traffic is really weighing down the mobile system, we can actually find models to move that data across to OTA spectrum and actually ease congestion and allow for more efficient use of spectrum. So at a very high level, that's some of the other applications that we're interested in exploring with ATSC3. We're also involved quite closely in joint research with CRC Ottawa and ATSC. On the ATSC side, we're involved in a number of specialty groups and implementation teams to help the standard evolve and develop over time. It is an extensible standard, so we're part of that active process with ATSC. We are involved in some specific research projects with a more defined roadmap with CRC, the Communications Research Center in Ottawa. That includes the development of an inter-tower communication network system. Our multiple tower system that I explained earlier will actually be formed as an ITCN testbed. And that will be one of the few testbeds in the world where partners will be able to come in and explore how we can start to make the broadcast system more intelligent from a tower standpoint, where you can do data handoffs from tower to tower, and you can develop an all IP data delivery system between towers. Part of that will take place through the evolution of something called in-band distribution link, which Willie may get into a little bit more later on in his presentation, or we can talk about it in the tour upstairs. And development of an SFN, which is what we eventually would like to form with our multiple TRX site. The creation of a broadcast core network is something that we're also very interested in participating in with ATSC, and we are doing that with them on a regular interval level. What ATSC would like to do, the North American broadcast industry is interested in developing a broadcast core network that can allow for point to multi-point services for broadcasters to essentially serve as a nationwide data engine. And again, this can support both television and non-television applications. So this is something that we're very keen to support. And again, I've left last in the research roadmap, our convergence with 5G. It's not very clear exactly where we're going to be converging with a core, but it's very clear to us that those potentials and those capabilities do exist. So a little bit more about the lab and how it works with industry partners. So we're here basically and set up to transfer knowledge and technology to our industry partners. Our projects work in a very novel way. If we have a particular partner that we're working with that has a solution they would like to create using 3.0, we would have the capability to engage with them in a very unique way that's supported by a lab grant that we're operating under. And if Company X would like to create, for example, a geo-targeting use case using ATSC3, we would work with them to develop what their objectives are, what the methodology would be, and what the deliverables would be. We would work to put them together with a faculty research member here from Humber who has expertise in that specific area. We would also then bring students into this lab environment, because students for us are at the center of the experience as a teaching institution. That's very important to us. And we would bring those three parties together to form a research team. We would then determine with the partner how long that innovation would take, 3 months, 6 months, 9 months, 18 months, et cetera. And we would then work towards developing the solution alongside with them. So that's where the technology transfer going to the partner is very beneficial for us by working through a team process. We're offering access to highly qualified faculty here at the college. The leading edge infrastructure for us is very key, which I've shared with you a bit earlier tonight. And a very innovator-friendly IP intellectual property policy. So any intellectual property that's developed here at the college with the lab remains with the partner. The college does not retain any IP, so the partner is free to commercially exploit whatever innovations they do create in the lab. And that's a very attractive proposition and really greatly supports adoption of the standard in Canada. So we're very happy that that's one of the benefits that we can offer. So this creates a cost-effective, low-risk environment. So research dollars can be spent in a way where that investment does return and hopefully recoups for the partner. And the broader goal and sort of an outcropping of the above goals is to become a knowledge hub for multi-sectoral applications of the 3.0 standard. So again, the primary sort of operating mandate of the grant itself is to foster partnerships between the college and the private sector. It's designed to work with Canadian SMEs, small, medium enterprises, but it also works very well with larger stakeholder groups, understanding that the cadence of creating arrangements and agreements with smaller companies may be different than larger companies, but we're open for business for any size of a company. All this facilitates commercialization, adaptation, and adoption of the standard in Canada, whatever way, shape, or form that takes. Development research funding is matched one-to-one. So if we develop a use case with a partner that, say, costs $50,000, a partner would put in a percentage cash and a percentage in kind. And that funding that they provide in kind and cash leverages greater funds and access to funds in a one-to-one match from the actual grant that we have. So if a partner were to create a $50,000 use case and they put 10% down, they would put $5,000 down, $45,000 in kind. Their $5,000 buys them $50,000 of research funding. And that's very important because it allows for the partner to have the financial flexibility and the wherewithal within the lab to actually create to create their innovations. As I've noted here, 150 students is our plan to hire over the next 5 years. That's very, very key for us. Again, the students at the center of the experience, they're going to meet a lot of industry partners. They're going to have a lot of great knowledge that they can amass and that they can carry forward in their careers. We're also looking at developing pedagogical frameworks for new ATSC3 courses here at Humber College and to instill those in various streams of our multidisciplinary college. So that's very key for us as well. As I've noted earlier, the innovator-friendly IP policy remains with the partner, and this is also an attractive proposition that all cash-in-kind partner contributions are SR&ED tax deductible. So that's also very key. And in fact, it's make or break for some of the small and medium-sized companies. So here's just a quick map, to recap our 3 primary locations. And you'll see I've noted in a 4th there. So Humber, where we're at, Site 1 right now is the North Campus. 110 Carrier Drive, just north of the college. Lakeshore Campus down at Site 3. And a proposed site at this point at the CN Tower that we're looking at to actually get us into downtown Toronto. So that's really key for us. And we're very grateful that Rogers is actually supporting us with technical support to help us develop our OTA test bed. So that, for us, allows us to consider how we move into downtown Toronto and how we can possibly continue to work with, in the future, with a series of broadcasters. So that, for us, allows us the ability to also test 20% of the Canadian marketplace if we're into downtown Toronto. And that's very, very key for supporting adoption of the standard in Canada. So with that, I will hand it over to Mr. Willie Perez.
So this is what we call the in Oresa, he said the in-love. So this is the in-love system design that I designed. And by the way, in order to do that, I flew to New Jersey, Tribini, in order to get some information. Since reading the book is something like, oh, it's not that easy to understand. So I have to get some more information from the Tribini guys who helped me design the system. So basically, the main system, the ATSC 3.0 system, has 2 components: the route encoder and the gateway scheduler. So the yellow ones. So the gateway scheduler is the heart of the ATSC 3.0. And it takes input from the route encoder, which takes only input as DAS format, DASH format. It doesn't accept any other format except DAS, DASH. And in order to do that, we have to use a DAS packager. At the center, there's a HEBC encoder as a DAS packager, which accepts multiple inputs, video whatsoever, SDI, TAS, NASI, and even IP. And then these are converted into HEBC format, H.265 compression, and then later on packaged into a DAS package, which is a 2-second frame or 2-second segment, and then sent to the guide builder. So from the guide builder itself, you will see later in our lab that currently I am transmitting 4 signals, 4 services, 1 4K, 2 1080p, and 1 720 in one 6 megahertz channel. So everybody are connected via networking. And here, the Tribini people proposed that we should do our networking separately. So before we are using VLANs, now we don't use VLANs, we put separate network equipment, network switches. So I have a separate switch for the DAS source, and I have a separate switch for the gateway output. And by the way, so the gateway, if you will look, it's a little sideways, okay? So I have to look on my, I have my diagram to help me, okay, on this. Yeah? Does this have a pointer, Tony? Tony, does this have a pointer? It should have a little red dot on the thing. No? Okay. Oh, no, this is a mouse. Okay, so by the way, so one of the input of the guide builder, the yellow one, is the cloud. And that cloud is that's the internet, okay? So that is connected to our DAS deck, the alert system, which is getting some signal from NAAD. okay, NAAD. And this is being sent to the guide builder, and I tested already that is working. And also, they are connected to the industry partner machines by the cloud. And some industry partners are going directly to our system through the local network. And I created an SFTP server in the system. It's very difficult that people really are. Yeah. Sorry for that. We have to really to make it correct, okay? We have to correct it. So, so the signal, so our industry partners, they're coming in through the cloud to the guide builder. The guide builder has an exclusive access to the cloud. They call it S-NATing. And the signal of the guide builder goes to the 1075 to something, and then it goes to the broadcast gateway, and then it goes to our in-lab RF channel, RF modulator that is having 8 channel. So we have a DECTEC 2115B that is capable of generating 8 RF channels from 50 megahertz to 860 megahertz. So band 1 to band 4.5. And also, we have a streamscope that monitors the signal that is that we are delivered, that is from the routing coder, and also monitoring the signal from the in-lab modulator. And unfortunately, I don't have a stick, so this guy is a monitoring system, same like your oscilloscope, but they are called now streamscope. This is also from Triveni Guide Builder. So in this one, it has 3 inputs. It has the routing coder inputs, monitoring if the signal is correct, and then it has the gateway output, monitoring if the gateway configuration is correct, and the data output and the RF input from the modulator if the signal is correct. So in that case, we can monitor stages, the guide builder output, the gateway output, and the modulator output. So we can monitor everything. And then finally, it will go to the over-the-air transmitter. And we know what is the over-the-air transmitter. And then also in this in-lab system design, we are going to do some data casting that we are using some Triveni dongle that we are sending some data. We are transmitting data, and the laptops are receiving the data via the antenna. I hope I can show you that one today, but not. And we have our spectrum analyzer monitoring the system. Now let's move to the next one. So in North Campus, so the output of that gateway, the yellow one, is going to the switch, and that is feeding our exciters. Originally, the plan is that we will have one transmitter with 2 mass filters. By the way, the license that we are applying is for 2 channels, channel 22 and channel 28. So that's why I have a band pass filter, a mass filter for channel 28, and a mass filter for channel 22. All sites have the same configuration. And when we communicated with the supplier asked us, or rather they provided 2 transmitters instead of having 1 transmitter, 1 exciter, so which is a better solution. So now we can use 2 transmitters for each site. So we can change the frequency of each transmitter every time we want, and that is simple. So using a 716, by the way, the connector that we are using is 716. We don't go for 7x8 or the N-type. The N-type, you know, the capacity is the power rating, because of the power rating. And the 7x8 is quite expensive. So we go to the 716 connector, the DIN 716, and we purchase the spinner 716 switches. And that goes to the RF 3-port RF pods panel and goes to the antenna. And we are going to receive the signal from the other side, from our receiving antenna, and we have a professional demodulator. The professional demodulator that we have is a DECTEC 2131. If you will notice, those I would not say all, but many companies are providing a professional demodulator for the ATSC 3.0. But what they have inside is a DECTEC 2131. Similar to the streamscope, what they have inside is also a DECTEC 2131. So we have the DECTEC 2131 as our for our professional demodulator. And since the system will be remote controlled, we have 3 sites. So I put the board controller to control the RF switch only. Take note. I put the board controller to control only the RF switch. At the same time, the board controller will control the transmitter itself. So we paid extra for the SNMP configuration for that, for the SNMP control of the transmitter from BARC. So this is for the VCTA is the North Campus, and then we have the TX2, the Site 2 carrier drive, and the next one is, yeah, that's okay. And this is the Lakeshore Campus. And what I forgot to mention is, in order for us to monitor the RF power, we are using a Bird BPME. So if you remember in the ATSC 3.1.0, we are using Bird BPME. We're using the same here, Bird BPME. And one thing also is that the switches are always connected to the dummy load. So I have dummy load to protect the RF amplifiers. So in case of wrong switching, the dummy load will take care of the wrong switching. It happens, right? So we have to be protected. So Ores mentioned about the ITCN that we are working with the CRC. This is one of the POC for the retransmission. So what we have here is that I'm going to send the signal, and this has been proven already working. So I'm sending the signal to the guide builder, and then it went to the guide builder in-lab modulator. Oh, see, I made a mistake here. I forgot what did I forget? The gateway. The gateway is missing. The gateway is missing in the diagram. So the in-lab modulator is getting the signal from the, oh, sorry. The reason there is no gateway because I'm using a DECTEC 2115. It has an internal gateway. So the DECTEC 2115 has an internal gateway. So it processes the signal and then goes to the DECTEC 2121. It demodulates, and then I fed back. Then I push the signal out of the 2131, which is already route format, to the DECTEC 315. A DECTEC 315 is also an RF modulator. It's a single channel RF modulator. And then I send that signal to the spectrum analyzer and to the demodulator in 2121, and then go to the stream scope. And here, I was able to monitor the signal from this modulator to 115 and the signal from the 315 of different frequency. One is channel 28. If you see here, I put channel 28 here. And here, I put channel 22. So the stream scope, I switches from channel 22 and channel 28, and I was able to receive both signals. So this has been proven working. That was before. So what I discussed to you before, a while ago, was before. Now, some changes happen, and that changes requires us to work on SISO and MIMO configuration. So this is now the SISO configuration. But before we go to the SISO, let us move to the MIMO configuration. The second one. Okay. So here, this is the MIMO configuration that we will be using another exciter. This is it has exciter A and exciter B. So MIMO stands for multiple input, multiple output. So now we need two amplifiers to work at the same time. So because we need two amplifiers to work at the same time, the gates exciter cannot do the MIMO. So this gate exciter can work only on SISO. So I introduce here switches that will switch the signal from this exciter. Oh, it goes back to, how do I go back? Oh, here. Oh. So these switches, you see currently is in the MIMO configuration, is getting the signal from the exciter A and exciter B of this MIMO exciter and being fed to the power amplifier that is now connected to the output of the switch. The two switches. This is power amp A and power amp B. So both are amplifier working. And then I put another mass filter here, channel 28. And this is the original mass filter, channel 28. And they are passing through another directional coupler for feedback. and going to the RF switch, and this time it goes to another RF patch panel and goes to the antenna. Now the antenna here is different antenna. This is a cross polarization antenna, 2 inputs antenna, horizontal and vertical. So unlike in the SISO, the signal is coming through here, the blue one. This is the signal path. And in the MIMO, the signal path is on the red one. So this is the configuration that we created. And I put pin diode attenuators. See, the main, one concern here is that it needs to be controlled remotely. And how do you do? How can you control this remotely? 2 sites to control remotely. It's not that easy. So Rogers Media provided us the Debicom control for controlling the attenuators. So this is thank you for Rogers for that. So now we are able to control the attenuator. This is still not done. Okay, this is still in the process. We have not received our. We still don't have the exciter. We got nothing except the attenuator. I can program the attenuator. I can check the attenuator performance and the switches performance. And for the receiving part, this is how the receiving of the system. So we have a MIMO receiver antenna getting 2 inputs from the antenna, horizontal and vertical, feeding the Avatec ATSC3 analyzer and feeding the TX-Link and MIMO manager. And then the output of the TX-Link and MIMO manager goes to the gateway scheduler that goes back. This is, by the way, this is bidirectional. Okay, if you will look here, this is coming from the Avatec ATSC3 analyzer also. So this is for MIMO testing. And, sorry for that, yes.
What's the GPS antenna?
The GPS is for synchronization. So we need to synchronize all the signals. So actually, we need only 1 GPS, but since we purchased 2 transmitters, they provided 2 GPS, so we have a main and backup. But everything will be synchronized with a single GPS or 2 GPS. Yes, sir.
What's your current RF power? RF power currently?
So the RF power, the power output of for the size, I'm speaking for the original plan. For the original plan, the TX1 is 400 watts from the transmitter. The carrier drive is only 15 watts. And this guy will be 200 watts. And that will be enough. For the MIMO testing, it will be it will be 10 watts or something. We have not done those calculations yet, but we will see. Yes, sir.
Do you have those licenses from ISAP for those for channels 22 or 28, or are you still applying?
We applied already, and Ores can answer that, yes?
We're just waiting right now from the City of Toronto to draft a letter of concurrence to ISED. So ISED has approved, but it's just the construction of the towers aspect. So once that letter of concurrence is written, that triggers the construction permit. We're ready to go. And
Will you have exclusive use of those in Toronto?
for the term of the license, yes.
It's just an experimental license, I guess.
Just a development license.
Development license. Okay, thank you.
Yes, sir.
Just curious how your emergency alerting works into that. Is it actually putting an on-screen overlay, or is it actually doing something?
Which one? I did not understand.
Is the DAS deck putting an emergency alert?
Yeah, question, yeah. Very good question. Okay, so in this original plan, the DAS deck is supposed to be putting the emergency signal or the alert in the screen. And unfortunately, we tested it. We didn't find any signal. And we asked people why we don't have the signal, and the answer is simple. The TVs that we have currently doesn't have the RA, the receiver application, running. They don't have it. Once they have the receiver application running, then we will get the signal. It's only broadcast application running now. So the receiver will be having 2 applications running, the receiver application and the broadcast application. Unfortunately, the receiver application is not running yet.
So the television would actually listen
I did not, believe me, I did not see anything, but we confirmed that the signal is being transmitted. But we have not heard from the TV. We did not hear that thing. So we are still working on how to make that thing works.
Yeah, we're still in the process of exploring the emergency alert piece itself specifically. So, is that a licensing issue?
Yeah. So by the way, for the dust deck alone, we went to North Carolina to check how they are doing this, and we found that they haven't. It's not yet. It's still in progress. Everything is in progress. It's not due to us, but it's due to the receiver application, which is from the TV manufacturer. So the moment it works, hopefully it works. And maybe the only thing that can be done here is through another source. What the other are doing is they provide a screen that will have those screen crawling, the text crawling, but that will be from the broadcaster side. So from the broadcaster side for the ATSC 3.0 emergency alert.
So are you saying that the units you have do not, the receiver application is not
Running yet.
working on it, or the whole receiver application thing is not running in ATSC 3 at all?
I cannot say that. In our TV, it's not running.
Our understanding is the receiver application work is still being refined.
Yeah. Yes.
Okay, so just a couple of last minute things. So this is getting recorded. Peter's going to slice and dice it so it looks pretty. Future meetings, either the 11th or the 18th, but now since I've done this slide, we're thinking about the 18th. We're going to have a meeting with Evertz IO Stream Technologies. November the 8th, we're not sure. Oh, sorry, that might be a Profusion joint venture with the guys at Vistech. December and January might flip, and February is student focus. We do a regular annual student focus where we get topics that are of student interest. And the rest of the year we're undecided. The technical conference, which we do every second year, this year we're thinking of, it is in June, but we're trying to figure out whether it's going to be a one-day, two-day event. But there will be topics like this and topics of interest that are current. Here's some information. So if you're interested in the link that Orst was talking about your the session that you had a couple months ago? A couple years ago. Send it to here. Just tell that email address or myself that you're interested in the link that Orst is going to share with us. So then that way I can get it to you rather than, I'm not sure we've got all your email addresses. Well, I think we do through the Eventbrite, so I could do it that way. So we can do it through the Eventbrite and.
You can make it simpler as well. Save on emails. Our new website will be live next week. b2convergence.ca. We'll be posting the videos from that seminar there. So there's a whole STEM to CERN set of videos from the whole seminar from various presenters.
Okay.
So that will give you kind of an end-to-end sort of core understanding of 3.0.
Perfect. That's it. And before we forget, I'll do a Vanna White thing. Our sponsors. So